Hey everybody, I'd like to thank Ford and ThreeDimensional Service Group for sponsoring this video. I'm especially excited about Ford once again leading the way for the other OEMs to EV adoption. Their thoughtfulness through engineering and manufacturing education really and truly is remarkable, and I'm very, very happy that Ford is sponsoring us. Thank you very much. Enjoy the show.
We're seeing EVs more every day. Good to know there's one that can still make people say, you don't see that every day. Because it's the only EV that's an F-150. The all-electric F-150 Lightning.
Hey boys and girls, welcome here to Cybertruck heaven, I guess would be the best way to put it. We're at the main building on the Gigafactory, and today we're going to take a deep dive into what's going on inside of the brand new Cybertruck. Now, I could try and introduce everybody, but we know that Sandy's not good at that, so Lars, can you kick it off?
Yeah, hi everyone, I'm Lars Moravy. I'm the head of vehicle engineering. I do most of the normal car parts on this truck.
I'm Franz von Holzhausen, head of design. Design Cybertruck, crashed a window, and make these guys' lives very hard.
Drew Baglino, I lead Powertrain and Energy at Tesla. So the batteries, drive units, the power electronics in the trunk, those are my baby.
Hi, my name is Pete Bannon. I lead the low voltage electronics and the autopilot hardware team. So my team designed all the low voltage controllers and the cameras and the displays and lots of little stuff. And
David Lau, run the vehicle software team here, work with pretty much all these guys and help them bring all their great hardware to life with software.
You know what? I'd like to start with you because because Pete, you have the thing that I know the least about, and I have to ask a question that I'm sure will be controversial. Why is it that you're not selling your software to all the other jamokes that are out there that have got 210 little boxes that each have their own software created by somebody else, and then they try and, communicate with each other? Have you ever considered, or is anything in the works to consider maybe just selling Tesla's complete software package instead of having these guys kind of do workarounds?
All the OEMs and tier one suppliers.
Yeah.
Yeah, I would say that hasn't really been a focus for us. Like we've been super focused on integrating as much functionality as possible with software and also with all of the hardware that we've brought in-house to Tesla. And we really feel like that integration is creates so many capabilities that allow us to deliver the product that we have right now. And so it's not really any one thing. It's not like, oh, well, because we did the software for this part, that's what makes the car great. It's really because we've been able to take a look at the whole system and say, how are we going to make all of these pieces work together rather than letting them fight with each other the way they normally do in a traditional automotive
It's
ecosystem.
a tight integration, right? It'd be hard to just peel the software off anyway.
That's right.
It's really tightly coupled to the hardware design.
I will say though, we also have been increasingly focused on enabling an ecosystem of software developers, third-party mobile app developers. We just released an API that allows third-party mobile app developers to develop mobile apps against
maybe that might be the answer then. Maybe what you could do is work with the supply communities, and somehow the OEMs could figure it out. Certainly the guy that needs to figure it out the most is that German company that starts with a V. I can't remember, but anyways, they seem to be, I just heard a few minutes ago that they're going to eliminate 40% of their production.
Wow.
Yeah, that's wow. And the other thing I heard was, guess what? The German government doesn't know how they're going to be able to make that happen because of all the rules and regulations that they've got. So who knows? You may be, getting into a sales role. eat shrimp, wear ties and stuff like that.
Yeah, I don't remember the last time I wore a tie.
Yeah.
Certainly not around here.
Well, let me throw one out then on the 48-volt system. As you may have heard, when we got the Model Y, the second one, we started tearing it apart. I was very disappointed that it didn't have. I thought it was going to have a 48-volt system, and there it was not there. So
Not for lack of trying.
not for lack of trying.
No, we didn't really try. I mean, part of the problem is that we have a tremendous amount of manufacturing capacity in place to build 12-volt things for Model Y, and we don't really want to rebuy all that capacity and retool it for 48 volts. So 48 volts is very much a forward-going thing as we redesign new cars and introduce new cars where we have to increase capacity. Then that's an opportunity, since we have to go buy new tooling anyway, to switch to 48 volts.
Yeah.
And that's sort of true for a lot of the capabilities across the car.
So how much of the system did you have to make? I'm assuming connectors, sensors. What else?
All the motors had to be
all-
redone.
Yeah.
A lot of the, there's even little simple things like how are you going to jump the car? So we had to figure out how to do a 48-volt car. And so there's a really nice switch tank converter circuit that allows us to detect whether you've attached a 12-volt thing and boost it to 48, or whether you've attached a 48-volt thing and then just jump the car straight away. So there's a lot of little things like that go into making 48 volts work smoothly.
Seeing as we're still on that, I had a look at something that made me caused me to think about things. Inside EV put out an article and showed a couple of blueprints, crude blueprints of patents that look a lot like we used to call multiplexing, but it says basically that maybe you've solved the problem of gigantic amounts of wire. Is that correct?
This episode of Munro Live is brought to you by the ThreeDimensional Services Group.
Hey boys and girls, I'm here with Dan, and we're at ThreeDimensional Services Group. And Dan, this is pretty impressive. Why don't you give us a little background on what you guys do here?
Okay, well, the ThreeDimensional Services Group was founded by Douglas Peterson 31 years ago. We've grown into the world's largest, most capable, and most agile prototype and low-volume manufacturer. In essence, we're a job shop on steroids. We work with the world's most innovative companies to validate their designs, and then we're able to take our low-volume manufacturing processes and scale them across a massive amount of equipment to allow us to support volumes that a traditional prototype shop would never be able to support. We're always working with our clients to accelerate their product development timelines and enable them to be as successful as possible by bringing their products to market as quickly as possible.
So you've got some of the big names here. Fuchs is one of the machines that most companies aspire to, but you said you've got 18 more coming or something?
16 coming over the next coming months, taking us to 88 machines in total. These are from brands like Starreg, Bavius, Hermle, Fuchs, Haas, YCM. We've got a variety of mills for a variety of applications. So metal stamping is the core of our business, and this press right here is one of the larger beds we have. This is a 1,500 ton press. It's one of 127 presses that we have company-wide. They've all got a variety of configurations allowing us to take on a variety of jobs. But really, this is the core of our business. We are vertically integrated from a tool design perspective, run all our own parts, and then laser cut them as well. So this is all handled in-house, vertically integrated at a significant scale.
So how many presses do you have then?
127 presses ranging from 20 tons to 5,000 tons.
5,000, really? What do you do on a 5,000 ton press?
Tubular hydroforming.
Oh, hydroforming. Oh, okay, good. Okay, so we're moved over here and we're now standing in front of a Trump 7040 Trump laser, and we're going to hear a little bit about its capabilities. It's got 5 axes, did you say?
This is a 5-axis laser. We've got 25 Trump 5-axis systems company-wide. This particular version is a 6 kilowatt machine. These are the finest 5-axis laser cutting machines available on the market. Yeah, so this is really the top of the line Trumpf equipment. Its software is integrated with our 2D lasers, allowing for us to cut blanks and instantly bring them over here and bend a perfect part repeatedly. We're going to be able to produce very, very precision parts very quickly at a significant scale with this sort of equipment. And we're very grateful to our partners at Trumpf that have given us this equipment to use here.
Okay, so Dan, I can see that we're moving pieces over here, and we're standing in front of some sort of a 3-axis welding system or whatever.
It's a cutting system.
It's a cutting system.
Yes, so this is our Trumpf True Store system. We've got a twin tower feeding a butterfly configuration, two 50, 40, 12 kilowatt 2D lasers are running off of this automation system, allowing us to keep these lasers running as efficiently as possible. The speed of these lasers when we get up to the power that we currently have absolutely necessitates this automation, allowing us to keep the laser running as often as possible.
You know, it's funny. Well, not really funny, but to me, it's very interesting. You have a pre-production facility that I'm sure pretty much everybody would die to have. I'm surprised that you're not. You may be the biggest in the world right now, but I'm surprised you're not twice as big, because everything you're doing here is things that OEMs and Tier 1s should be doing.
Absolutely.
And I've seen progress slow right down with other companies, with bigger OEMs of any type, whether it's aerospace or appliances, whatever. They always slow down because they try and do it internally. This is the best thing as far as I'm concerned. And looking at what you've got going on here, it seems to me that if I was in that kind of a situation, that's what I'd want from you. So that's my assessment of everything I've seen here today.
Yeah, we appreciate that. And we want to work with the world's most innovative companies. We want to work with the companies that want to go fast and really change the world. We are a job shop. All of the capabilities that everybody's seen here are available to anybody that wants them. It's as simple as just sending us your data and getting a project started.
Thanks to the 3Dimensional Services Group for sponsoring this video. Whether you're looking to source metal stamping, precision CNC machining, laser cutting, welded assembly, or plastic injection molding, the 3Dimensional Services Group should be the source to transform your EV, aerospace, appliance, or technology designs into reality, while also providing a bridge to start of production.
Well, I mean, 48 volts doesn't reduce the number of wires.
Well,
it just
let me rephrase it. It enables one other thing. We used to call it either communication or whatever over power. Is that? Are you using?
We looked at that really hard, but the power system is extremely noisy, and you can make it work, but it's hard. And so the cost of 2 more conductors to have a really clean communication system it's just worth it in our minds.
Although we are doing some interesting things with communication on the truck.
Oh yeah, so we have switched to Ether loop. So we have a gigabit Ethernet loop in the car that connects all of the high-speed controllers together. It's bi-directional for redundancy, and that's turned out really well. So the number of wires that go across the car has been reduced dramatically, even though the number of endpoints went up. So the total mass of wires is way down, and the average length of wires is significantly shorter. Because
then we can put the endpoints where the controllers are, right, rather than putting the endpoints wiring, like routing a bunch of wiring to an endpoint that has to connect to a controller halfway across the car.
Yeah. So like audio flows around on Ethernet and gets distributed to speakers all around the car. Then there's no audio overlay for wires.
In one of my YouTube things, I said that if you could do, and I didn't think of maybe an Ethernet loop. But one of the things that I suggested was that could probably eliminate about 80% of the weight associated with communication wires. How close did I come?
I don't actually know that number, but
What? Oh my God!
But overall, between Etherloop and 48 volts, the mass is down significantly. Yeah, I don't know. It's half.
Half.
We'll have to follow up for you.
Yeah, we'll double check our homework.
Okay, well, half is still quite a bit. Half, that's got to be at least 15 kilos or something like that.
I mean, the Cybertruck is a lot bigger, so it's sort of like on a per unit basis. You have to compare it to be fair. Right?
Yeah, there's.
Yeah.
I wrote the numbers. I have a cheat sheet.
So do I.
Because I didn't remember all
Fortunately,
the
I
numbers.
haven't had to reach for it yet. These are off the top of my head, but
Yeah.
oh my God!
So
you got small printing.
So Model 3 has 273 endpoints, and Cybertruck has 368, so 50% more endpoints.
That's a lot more connections. Yeah.
And the number of wires that go across the car went from 490 to 155, so it was 68%
Wow,
reduction.
that's three quarters.
High-powered harness mass went down by 84%.
84%
for high-powered loads. Yeah.
Really?
So that helped a lot.
I mean, yeah, like
that's a hell of a big
the steering
number.
system, right, on a 12 volt. When you get a thing this big, it's got to have like, 18 kilonewtons of rack force.
Yeah.
So the motor, like the wires are like,
yeah,
2 4-gauge wires, and with the 48 volt motors, they're significantly smaller.
Yeah, and I think we found that like when we were looking into whether this would be worthwhile or not, 48 volts that is, we looked at, okay, it's going to be really hard to convert all of the loads, but what we found was that I think 83% of the power, peak power, comes from 13% of the loads.
Devices. Yeah.
So like we attack those 13% and we get a huge benefit in terms of sizing for those.
And also it was, Pete's not maybe fully taking credit for it, but it was, the 48 volt was not just a voltage choice, but also a, how do we logically distribute the functions? And what are the vehicle controllers doing? How does the power conversion happen? Because eventually, a lot of these microcontrollers, they're running at 0.7 volts or 1.3 volts. So you have to do power conversion from 48 anyway. But so it's this thoughtful lumping of functionality so that you can use the ether loop plus the 48 volts to have a minimum number of controllers that do the most amount of work. And that also is a virtuous circle, because like the more stuff you get into one controller, the more like value you get out of that 48 volt connection, right?
Another unexpected benefit of Etherloop was just debuggability of the car, because all the data for everything in the car goes over one communication link. You can connect your laptop to it and see everything, and it's all synchronized in time, so you can see exactly what the car is doing. Whereas in the past there were multiple CAN buses, and you'd have to, you'd be connected to one CAN bus and go, missed it. Go to a different CAN bus.
And furthermore, like the amount of like debug information you could put on a 500 kilobit like theoretical peak bandwidth CAN bus is 200 times less than what you can put on a gigabit Ethernet.
So let me ask a dumb question. Like I say, I'm not a software guy, but with this kind of system, does that drop the number of lines of code that you're going to need, or
drop the number of lines of code?
I mean, there's at least on the communication side, it
is a much more like homogeneous system.
It's homogeneous. That's what it is.
In that we've got a very small number of, let's say, like Ethernet, like basically little routers that then fan out to smaller CAN buses.
Yeah.
For particular like localized purposes. I wouldn't say it necessarily reduces the amount of code, but it sure makes it easier to develop on and debug, because you've got so much more visibility. And what you basically have at that point is a software-defined network. Like it's not like a statically defined CAN bus. It's like completely software-defined. We can change the way messages route and who they go to, and listens to them completely in software on the fly.
Yeah. It's also like, even though it's Ethernet in name, but it's not like Ethernet protocol in practice, because like regular Ethernet has randomness to it, and packets can be dropped and stuff. So the way we use Ethernet as a transport is quite fixed and planned, and it's time sliced. So it actually looks a little bit more like a token ring network in that regard.
Yeah, it's basically a TDMA network, which means that like each like Pete said, it's time sliced and like in a highly deterministic way. So we are confident, similar to the way you are with a CAN bus, that the behavior of the network is going to be determined.
You don't have variable latency. You
Yeah.
can't have variable latency.
We're seeing
That's the
synchronization
next
at a
thing I was going
microsecond
to ask
level.
about was latency. Did this, well, you already answered the question, I think, but this improves latency. You should be able to get communication done faster.
Millisecond scale latency and
Yeah.
microsecond scale synchronization.
Yeah, microseconds. is
Because we also have audio flowing over that same network, and bidirectionally too, because when we're doing active road noise cancellation, we've got
Yeah.
data coming in from microphones and other sensors that then has to get processed by an algorithm centrally and then fan back out to the speakers
yeah.
to actively cancel noise. So that synchronization and latency is hugely important.
But I will tell you, I was one of those people, love it, hate it. When I saw that thing come up, boom, I was on board immediately. To me, I mean, I've seen enough roundy cars. I worked on the very first one. I worked on the Taurus. And it used to be
Melted
that
butter
you got
Taurus.
2 bricks, clunk, clunk, and there's your car. And that was it. And then the Taurus came out, and I was there when Henry the Deuce took the first look at us. It's crap. You're putting the company completely out of business. And when I saw this, everything's roundy, everything is kind of like the same jelly bean, and this one here just totally blew me away. I was very, very impressed.
What was a unique opportunity to have a vehicle that really wanted to be tough on the outside, to create an exoskeleton that made the form actually be a result of the function. So I think if we do this for another vehicle and we're not honest about why we're putting the toughness and the stainless steel that drives basically the form, you can only bend the steel in one direction. And it's much less of it's more of a style thing. This is really, a through and through kind of design solution based on what you can and can't do with the materials. That makes sense.
The material is one of the questions that I do have, and seeing as we're sitting in front of it, I might as well ask it. Okay, so true stainless steel starts at about 316. What is this one here? That 30 whatever
Yeah,
XX.
it's a if you look at 316 or 304, you have different levels of cobalt and nickel to change the various parameters of it. The reason we called it 30X, we actually just changed it. We call it HFS now. Hard freaking stainless.
Very good. Yeah, I love it.
And the reason is it's in between all of these because we had to balance the corrosion toughness, some of the lower grade alloys with the ductility of the higher grade alloys. And so the balance was really, as you know, stainless isn't stainless. It rusts.
Yeah.
And so we had to make it super rust, corrosion preventative because there's nothing on it. And so we balanced that, and then we added a little more ductility because once you roll it full hard, you really can't bend it that much without cracking it. So.
Let me ask.
No, it's not.
It's not.
Yeah.
I don't see any bruises, so
No.
you're not making it in a press brake.
No.
Is this up? Here we go.
Yeah.
I'll take you out there.
Here, hang
I'll
on a
show you.
second. Okay, so let's see. Okay, so how would you classify this
The
bending
forming
operation?
process?
Yes.
We
forming.
call it air bending.
Air bending.
Yeah, and so basically it looks like a press brake, but we're shooting high pressure air on a bearing that's floating the steel. So as the brake moves up and bends it,
So are you doing it cold?
yeah, we're doing cold.
Oh, all right.
See?
That's wrong.
I know.
And
Rare-
it just
a rare
float-
moment.
It just
A rare
floats.
moment.
It
No,
float-
I'm wrong a lot. Just ask any of my people. They'll tell you.
It floats the air, right? So
Yeah.
and then you get that cushion of like a air hockey table almost underneath it. It's just so you don't get the bruises on it, and we don't see that orange peel or that mark from the brake. And then we have full. It's all computer controlled, right? So we have full. You get some spring back, and then we can come back and
Do a double
redo
bend.
it if we need to. So that's why we get the precision. And then you dial that in, and you get one batch of steel, it works fine. Maybe the next batch we'd have to readjust a little, but the computers do that for us.
Here's a tip.
Yeah.
We don't have a purchasing people here right now, but purchasing was always the guys that buggered me up when I was trying to stamp anything because I got a sale, and the next batch of stainless steel isn't the same as the other one. So the other one is
This
is
is specific heats for us, man. Like
Yeah.
no one else is buying this.
Oh, really? Well,
Yeah.
then that's cool. That actually is favorable to the guys on the floor.
Yeah.
But okay, so why don't we do this? Why don't we start talking about your boron or high strength steel here?
Yeah.
And I already asked a couple of questions about whether you're using tailor welded blanks and stuff like that. So if you can just, let everybody know what's going on.
Sure. So, I mean, when you look at the Cybertruck, everyone thinks about the skin and how tough it is, and we can talk about that and whatnot. But the other cool part of the exoskeleton is actually this door ring. It's the world's largest door ring. Hot stamp door ring. We do it in-house with a tailor welded blank. And there's no body side outer, right? There's no skin over this. This is the A surface or the B+ surface that's on the door inner. And it's simply coated with a black powder just for aesthetics, basically. So we're looking at a clean surface here, but it's high strength boron steel, single piece inner and single piece inner and outer, and then we just spot weld it together. And we do that down here at the south end of Giga, Texas, because we had to, much like our castings, we had to make the press.
Yeah. Well, stamping press of this. Whose did you buy? Schuler's or?
So we have two different brands. We have Schuler and AT&T. Yeah.
Yeah. Okay. So if I was going to do it, that's who I'd pick, mainly because I can get the tonnage and the reliability.
Mm-hmm.
So that would be my first choice. So at the end of the day, I noticed there's you've got sealant in here, and then I feel I can feel spot welds, but I don't know what they're spot welded to. So this would be.
Well, the door ring ends here, right?
Okay,
and it kind
so
of
that's
flange
where
here, and this triangle is an extension, just
okay.
like there. So this is actually
so this
the door
would be
ring
the
inner.
shotgun under
Yeah, this is typical shotgun, right?
Yeah.
And then our casting starts here, right? It's hard to see. Maybe we can go around the other side.
Well, you got one right there, right?
Yeah.
We can use this one.
So this casting here is like right at that A pillar, and it's bolted to the door ring here, and that's where you see the sealant come up through the A pillar.
Yeah.
And that shotgun comes down to about here, because it's one straight line, right? So we don't have, normally the windshield would come here, and then you'd have the hood here.
Yeah.
But this is a pretty big casting. It's pretty.
It's
not as big as that one.
So is this like 8,000 tons?
No, this is actually a 6,500 ton. The rear,
Are you kidding me?
The rear is 9,000 tons. Yeah.
How? Okay, so how
it's
did
just
you
about
keep it
flow,
together?
right? Like you gotta, like when you think about tonnage, it's about how much metal you're moving within the platen size and how fast you're moving it. But you can restrict that metal flow by like making bad, feeds in bad directions. But when you look at the side, the flow, the biscuit comes in through the middle there.
Yeah.
And then we flow it all out, and we do it like a river, because like liquid metal wants to move like a river. A lot of times when you see these people copying us, and maybe I'm giving it away stuff, but it's an engineer drew it, right? And they drew triangles and trusses.
Yeah.
Great. But here at Tesla, we have in-house die designers that sit right next to the guys that are designing the castings, and they're going back and forth on simulations so that we can lower the tonnage of the presses we're using by integrating the design of the part into the design of the tool, which is why we don't need necessarily 8,000 ton press for the front. When we started, we thought we would. We said, we're gonna need 8,000 tons. But we worked through the team, and we actually can make this front one on the same equipment as we make the Model Ys.
That's,
not the rear one.
That's amazing.
The rear one's too big.
Yeah, well.
Helps with cycle time too, right?
Yeah, it does help the cycle time because you get more even cooling across the whole thing.
Well, that's the big thing, cooling and warpage. Everybody asks the same question. I mean, how much does this warp? And I said, well, it happens so quickly, it shouldn't warp at all. But
yeah, I mean, it's really about how long we cool it in the die, and you let the skin cool, and then when you pull it out, we don't have straighteners or anything.
So how many presses are pushing these out now?
We have one for the front and two for the rear, but as I said, we have the Model Y ones.
Yeah.
So we have four of those. We could swap the die out. But we only need two. Cycle times are down enough to make, 5,000. We only need two presses, one for front and one for rear.
So at the end of the day, 5,000. Do you bother with backup tooling then?
Yeah, we swap the tools out.
Three sets of die?
So, at least two. If we're running one, then we have one backup. Otherwise, we'll have two in and one backup, and we'll rework the one while we're running the other two. And when casting machines go down, they go down hard.
Yeah.
Right. And so you got to get the tool out and get a new one in quick.
Right. Yeah.
And so we always have a backup die, or it's not even really a backup. It's like we cycle them. Right. We're just rotating and maintaining them. It's always.
So maintaining, I would have thought. Well, it depends on. I don't know enough about this aluminum to really I mean, we did an analysis on it, but I've never worked with anything quite as exotic as this. So what kind of, aluminum is nasty for molds. It's very corrosive and whatnot. And so how much time are you spending then on?
Well, how we do it is we have inserts in the high heat zones.
Yeah.
And we have those inserts, and they might be coated with like a nickeloid coating or something on it to prevent that damage from that local area. And then we have our own in-house die shop. So if that area is getting weak, we'll just replace it with a different insert.
A new
and then
insert.
the platen is really what lasts you know, hundreds of thousands of shots.
Right.
And you know, we may be maintaining the inserts, you know, every couple months, every 6 months, but you know, we are making a lot of dies, which is why we made our own die shop.
Yeah, good idea. Yeah, a lot of people. Well, most people are using co-stamp, I guess. With their puzzle molds, which I don't quite understand. But anyways, that's where most people are going. And if you're doing it in-house, this is what made.
You like these?
Yeah, I do.
So you know what's cool about these ones on Cybertruck? They're actually tapered because we didn't want to machine this.
Yeah.
So there's no machining for the holes or anything.
Yeah, so you just shove them in.
So we just twist them in self-tapping and they're tapered. And we have the external for the bigger ones, and then some of them are internal for the smaller ones. But.
And these ones here look like they're going to get a
These are
screw
self-tapping,
hole.
just
self-tapping ones. And this is the way to make it work. I didn't know you were doing inserts. So
yeah, I mean that's just really about
high
torque retention.
strength. Yeah.
But the other cool thing about the Cybertruck casting is we actually extended it forward. Most of our castings stop here, and we have a crush can. This is actually the crush can actually is sort of integrated into the bumper, which is aluminum extrusion. And then this is actually the first part of our progressive crash mode, which means it's even bigger, it's longer, and we're incorporating more and more parts. I can't give you. Someone asked me an equivalent number, but we never designed this one without it, so I don't know.
At the end of the day, there's a couple of things that people don't quite understand, and one of them is how do these things crash and blah blah blah, and let's just swing over there.
One of the things on the crushability, Sandy, and I'm sure you've seen, is we have different size fins from front to rear.
Right. Yeah.
So we have controlled chaos in the crushing. You can see it even here, like how these build up, and that's so that we know this is going to break first. That section's smaller, the ribs are lower, and then this will get second because each one is progressively stronger.
Right. So, what is this thing based on? What sort of
physics?
Either math or mass, I should say, or speed, or what have you.
I mean, the rear crash, of course, we're trying to absorb 305, which is like a 50 mile per hour rear crash. But like really this structure is based on the like primary vehicle design, all the suspension loads go through here.
Yeah.
So we're trying to get our torsional stiffness from this. We're also supporting the bed loads, it's 2,500 pounds, and the towing loads, which is 11,000 pounds. And they all go through here. When you put all that math together, right, then you end up with sort of like an elegant load path structure of trying to get back to our nodes at the batteries and the corners and from back here. Then the crash really just becomes a fallout of how do I keep that stiffness where I need it for all those loads to be distributed, and then what can I absorb, when I get hit from behind. But crash is actually the simple part of these designs now.
Yeah. Well, for me, I bent the daylights out of the Model 3 when I hit it with a sledgehammer. And granted, that's an 18-pound sledge.
Yeah.
That's not the kind of thing you normally swing around. And I didn't have good access. When I hit the other castings, like the Model 3 casting or Model Y castings, I mean, it just bounced off. And in the in the movie or video or whatever, I swung down and hit the shock tower, and the damn thing came popping right back. And then I found out that my knee didn't like it. So, but there was no damage whatsoever. And I'm thinking that this is less likely to crack or break or do whatever than if I have a bunch of welded sheet metal together.
Yeah, I mean, certainly it's more homogeneous, and it's quite ductile despite its appearance, and so you get a lot of flex with it too.
So we've got the dual motor setup, front and rear dual motor. I mean, maybe one thing I'll just say is we kind of have a platform approach to the Cybertruck. We've got 3 different powertrain configurations, but we only have 1 PM rotor stator, 1 IM rotor stator, 1 inverter, and 1 gear set. And so, but with that, we can do a rear-wheel drive, a dual motor, and a tri-motor.
Right.
So it's scalable from like 315 horsepower on the low end to 845 horsepower on the high end.
Well, the one thing that I've made comments on a lot is the fact that you do a lot of what would be the right word, standardizing on the bits and pieces. And the others can't seem to quite make up their mind. So it takes a long time for them to figure out that, hey, maybe it'd be a good idea if I standardized. So
yeah, this is the same 4th generation drive inverter that you can get on like a performance Model Y today, is also in the Cybertruck, although it is the 1 kV silicon version, but otherwise it's the same footprint more or less. If you took it apart, you'd be like, this looks very similar to what's in a Model Y, even though it is running at 800 volts in the Cybertruck. We've got, the configurations are, for a tri-motor, we've got 2 induction motors in the rear, 1 permanent magnet in the front. For dual motor, in dual motor, the PM moves to the rear and the induction motor's in the front. And then for rear wheel drive, it's a PM in the rear. And that's kind of what the family looks like. The tri-motor does 0 to 60 in 2.6 seconds, rollout removed. So it's pretty performant.
It's the first time in a long time I had to struggle with tires being...
Yeah, tires were the limit.
The limit. I can actually go a little faster if I can make some stickier tires.
Yeah, but 2.6 seconds rollout removed is, for a truck.
2.6, that's
pretty impressive.
That'll definitely get you to where you need to in a hurry.
And with a single one of these drive units, and this doesn't look very large. This moves the whole truck in under 6.5 seconds in the rear-wheel drive configuration, and can still tow 7,500 pounds. So, significant capability.
I thought it was 11.
Dual and tri is 11.
Oh, I see.
Yeah, rear-wheel drive 7,500. Yeah. But other than that, you'll see a lot of familiar parts, like even down to the oil chiller, the oil pump, a filter. Even the
this is the same one that's on my wife's tractor.
But yeah, when you take it apart, you'll see familiar pieces. The actual size of the rotor stator is actually smaller than it is in a Model 3.
No kidding.
Because we're taking advantage of the gear ratio, the fact that the top speed is lower. So this is a 15-to-1 gear ratio. So
what is the top speed?
130.
Yeah, 112 for the lower.
And you've got, big...
It's fast enough to go through a swamp. Yeah, good.
The one way to think about it is, in terms of rare earths, because I think that's one thing that you've been tracking, we still do have rare earths in the Cybertruck, but the amount of rare earths in the Cybertruck is no more than that of a Model 3, but it moves the Cybertruck down the road.
Cool.
So yeah, they look pretty similar to what you've seen before, but they...
Well, actually, we've never taken apart a hairpin motor. None of your hairpin motors.
These are hairpin motors.
Yeah, so it'll be perfect if I could get a hold of one. Well, unfortunately, I couldn't find a job for electrification in the U.S. So I spent from 2014 to 2019 in China. And one of my rules was every engineer 1 gram every day.
Nice.
And guess what? It in the beginning, look what I did. And then at the end, oh, God, it's not possible. Yeah, so they were actually going in and drilling out the center of the heads of bolts and stuff like that. It was a good, hey, you know what? If you take a bunch of grams and you glue them together, you get a kilogram. Yeah.
Yeah, no, but through optimization, it literally was a game of kilograms that we pulled out when you consider the tri-motor.
Yeah.
That's one of the coolest things about Cybertruck. The mass of the thing is just like, it's about 2950, 2980 kilos. So, what's that, 6,700 pounds? 6,800 pounds? It's like normal big truck stuff. Right. Even though we've got, massive, I don't want to, bullet resistant doors and, 3 motors in it and giant battery.
That's usually the big killer with stainless steel. I say it just weighs too much. There's no way we could survive with that. But if you can reduce a lot of the internal structure, doublers and triplers and whatever,
or all
then,
of it,
yeah, good. We can do the controller first. Yeah.
So this is the left controller in the car. So it's 48 volts. This is one of the ether loop connections.
Have a peek at that. That does not look like an ether cable.
It's a standard twisted pair shielded cable. Yeah. And then this is another one going to the rear controller. And then this right here is the switch tank converter. So that does 48 to 16 volts and it's bidirectional. So when I was talking about jump posts, on the jump post, the current flows back from a 12-volt battery to jump to 48. And then one thing that's different is this is mounted on the firewall, and so it spans the wet side and the dry side, which is new. We haven't done that on the 3 and Y. So one of the things that can happen is circuits on the wet side can come through and just transit the board and then go back out, and that allows us to remove a whole bunch of grommets that used to go through the firewall. What else is cool? Because the current's much lower, the eFuse circuits are much smaller. I can't even point to them. They're all like up in here somewhere.
Yeah, they're really tiny.
Yep. And then this is the microcontroller that runs the ether loop.
Really? All by itself? That's amazing. What's this chip doing here?
That's another microcontroller that does a lot of the PWMs for like controlling window motors and things like that.
Mm.
Yeah.
It looks really compact.
It is.
Dense.
Yeah. Well, the problem that we're facing now is that it's dominated by the connectors. So if we could get rid of all these connectors or densify them, that would be a lot nicer. And we've been using this style of connector for quite a while, so we're just pinch stitching on the module, and then the connector itself is formed into the cover. So this, when you see it in the car, the cover on top of this forms the body that the connector actually connects to.
Yeah.
So we don't really, buy connectors. Like for example, like this one where the the shield is already in there. So that's pretty fun. And then because of 48 volts reducing the current, that reduces the loss. So when you see it in the car, the heatsink is significantly smaller. And really one of the reasons we have the heatsink is the audio amplifiers are here. Yeah. So we used to have a separate box in the car for the audio amplifiers, and now we've been able to integrate them onto the car. Yep. These are still 24 volts. But in the future we'll push that to 48 as well.
If you like, one of the things that we had when I was trying to push this in the 80s, 48 volt, I thought I couldn't understand why we're still using 12 volt.
Right.
And one of the reasons that I wanted to do it was because I could get rid of almost every heatsink in any of the, because it's old fashioned, right? Mm-hmm. And by going to 48, I could get rid of those heat sinks and, they're cheap. Or, everything was, nobody cared about mass. In those days, it was road hugging weight.
Really?
That was,
we have enough of that.
Yeah.
But I squared R, you reduce the voltage by, you increase the voltage by 4x, reduce the current by 4x. It's 1/16 the heat.
Yeah. It's huge. 16th, yeah.
No, we like it.
That's a good idea. I can hardly wait to see who comes in second. It always seems to me that you guys pave the way and then everybody else becomes an expert. And usually the guy that comes in second, Wall Street throws rocks at them as well, saying that, they've done another dumb Tesla thing. And that's what happened with, what's his name? Jim Farley, when he went to your connector, the North American. Yeah. And now everybody's done.
He looks a little smarter now.
Volkswagen. Volkswagen is not good. Yeah, well.
That domino will fall eventually.
Yeah. Yeah. So here we are.
Yeah. This is you've taken apart a couple power conversion systems. I know.
Yeah.
So this is
none of them look like that.
This is the next generation power conversion system. We call it the PCS2 at Tesla, where we've gone to everything being surface mount reflow process and no whole through hole based parts. We've got
these aren't through hole.
No.
Wow.
And these are all planar magnetics. So none of these, you can almost look like they were made by hand. The large inductors and chokes that you saw before, all planar magnetics, leveraging the PCB. You can see the traces in the PCB that are part of the circuit there. We've accomplished a doubling of volumetric efficiency from a power density perspective and a 50% increase in gravimetric power density. One of these PCS2s in the truck does 11.5 kilowatts continuous bidirectional on the charge port. So you can power the house.
Okay, so that's the other question I had. Can I power my house?
You can power your house, 11.5 kilowatts continuous, 110 amps of inrush current capability for, you've got your air conditioning units or whatever in the house. We've got 4 120 volt outlets and one 240 volt outlet The 240 volt outlet is in the bed, so you can just charge another EV right off the back, or do whatever you want to do with 240 volts. And we've got 3 kilowatts of 48 volt power, all in this object. You've got your 4 power stages there on the high voltage side, the 2 power stages on the 48 volt side.
So what does it look like if you get the extended range version? Because I know that there's something coming out with extended range, right?
What is this? What does
The
this look
extra
like?
battery pack.
Yeah.
Does that?
We can show you. I mean, it basically sits kind of in the bed.
Yeah, it looks
raises
like a
the bed a few
toolbox in the
inches.
bed. That's what it looks like.
Oh,
And you can get over 460 miles of range with that extender.
460 miles. And what would that be? if
Long-term
I was
target is
charged-
500.
That's right.
What about towing and whatnot? If I have an 11,000 pound thing that I'm dragging around, what does that give me? In
Yeah, I mean,
way
it
of-
depends
Yeah.
on the aero
It's
efficiency
less the
of
weight
thing.
and more the aero.
Yeah, it's like, if you pull a horse trailer, it's pretty bad. Maybe take away 50% of your range. But if you pull a Ski-Doo or, something a little more aerodynamic, you might be able to 20 or 30%. I mean, the cool thing about Cybertruck, Franz did a good job on, was that tail really gets, with the tonneau and everything,
Yeah.
it gets the air flowing fast and
Yeah.
it makes a taper. So we get pretty good straight laminar flow off the back.
Right, yeah.
And as long as that's not getting disrupted by whatever you're towing, it's really just the mass,
And also,
losses.
we're scaling up regenerative braking power based on the mass that we sense inside the vehicle.
That's
so we're
right.
doing our best to recapture as much of that energy as possible, so we don't at least waste it on friction brakes.
But yeah, with the range extender up over 460 miles. And obviously, if you're somebody that tows a lot, like, I don't know, San Francisco to Tahoe, the range extender might make sense. But
Well, the average person drives 40 miles
a day.
I mean, it's like
that's why we
I-
decided to make it an optional add-on.
And I mean,
Yeah,
most people,
exactly.
340 miles, 320 miles, what we're gonna give in the dual and the tri, like that's totally fine, like for anybody. And then we want to make more electric vehicles, right? So like rather than putting more cells in that no one's ever gonna use,
Yeah.
if you want it, you can buy it. That's the
Well, I don't see the need for, at least for me, anyways. If I'm going to go into the woods with something like this, I'll charge up before I take off. And if I decide to lose my mind and, travel some other place that maybe I shouldn't have,
Use the charging network.
exactly.
Yeah.
And that's it.
One other unique thing that we're doing in the Cybertruck is we're actually able to natively charge at both 400 volts and 800 volts. So we actually take the battery and split it in half.
Really?
When we're at a Tesla supercharger station that's a 400 volt station. So rather than having to go through a boost converter that could be slower and efficient, we just directly connect the supercharger to the battery terminals, whether it's at 800 volts or 400 volts. And that's all happening with this. It's a dual pole, dual throw reconfigure of the bus. You can kind of see here the bus is in parallel, there it's in series. And that's what's happening in our device cluster area of the battery pack, where we've got the pyro devices, we've got the main switches, and then we have this DPDT, we call it, that configures the bus between a 400 volt bus and the 800 volt bus. Which does mean that things like the power conversion system, the HVAC compressor, and everything else need to be able to work at both voltages, but actually that isn't very complicated when you think about what they are. They're all variable speed drives, variable frequency drives that have power converters in them already, and they're already designed for the higher voltage, so they can run at the lower voltage too.
Cool. Way cool. Okay, now we're into where I actually
Chassis parts?
even more interested in, and that's steer-by-wire.
Steer-by-wire. You asked
And
for it on Model
I
S.
did.
We did it on Cybertruck.
I thought you were going to bring it out on the Model S and
Similar
scare
to
the
48
crap out of
volts.
everybody.
Sometimes things take a little bit longer to bake.
Yeah. Well,
Yeah. I mean, between David and me, this is a labor of love, I would say. There's a lot of functional safety that went into this. But, it's a typical steering rack, right? We went to a pinion drive on either side because, you don't need like the feel that you might get when you're driving because, the feedback actuator at the wheel handles that. But these are two smaller 48 volt motors, in-house designed, and we work with our vendors to make them, but they're roughly 50-60% of the power capacity we need. And so most steering capacity comes at like parking lot loads when your brakes on and you have to scrub the tire. So we didn't want to oversize these to do that. So if there is a faulted state and you lose one motor or one controller or one side or one power bus or whatever, you can still drive quite easily on the other motor all through the highway, pull over safely, whatever you want to do.
so that gives you a double redundancy.
Yeah, it's double
And
redundancy.
actually, like while you're driving normally, like 50% of the torque is coming from each one of those two
Yeah.
motors.
Make sure
And
they're
the same
both
thing
working.
on the
Right. Which is a good idea because in aircraft, we've been doing this
Doing
forever.
right?
And
You want to be redundant, but you also want to be differentiated. So you can see on this side, we don't have an angle sensor, but on this side we do. This side we have a position sensor, just so that we have different signals coming in from different motors.
Diversity of different sensing modalities
and redundancy.
and computation as well.
Here's a cool trick, though. This is a rear steer one.
okay, so I know well, we've done this on buses and things like that, but we've never seen anything like this on.
Well, it's a big vehicle. We wanted it to drive like a sports car, and so make rear steer's the ticket to make a big thing feel small. We get about 10 degrees, 8, 9, 10 degrees of rear steer with this per side, and that's mostly at low speed.
Hang on. Cannot believe it.
So we get about 9, 10 degrees of rear steer with this thing, and the cool thing is this motor is the same as this motor. So the controller and everything, we have 3 of them in a car, and they're all the same.
Oh man.
Back to the reuse thing.
Yeah, I learned that one from Drew.
I do not understand why it is that there's. I can tell you why. Well, I do the front steering, and he comes up with something. Well, I do the rear steering, and she comes up with something different, and then we.
Same team.
Yeah, same team.
Same person.
Good idea. Same person. You can't go wrong with that. Yeah.
You really notice the nimble drive with the rear steer.
Yeah, it makes it feel tiny.
Yeah, it completely changes the feel of the
Does
car.
it spin on its own axis or something?
No,
like that?
it's not that. I mean, but when you're turning, it feels like your yaw center's behind you, which is kind of cool because you sit a little bit more forward. So, it's super easy to move around, even though it's a big truck.
So lock to lock, what have you got?
Less than 1. It's 340 degrees.
That's a good idea. What about
Never have to take your hands off the wheel, so it's variable at speed, right?
Yeah.
So we get a little bit slower ratio on the highway, so it's not as twitchy. A little bit faster when you're in the parking lot, right?
Cool. Oh, excellent. And what?
The last part we got to show, I guess, this is we have about a little more than 12 inches of suspension travel. We want to be super great off-road, and so we have air suspension on all 4 corners, and then we have adaptive damping, to make it ride well when it's low or off-road or high. And we have independent control of both compression and rebound valves, so that we can switch with that ether loop communication system at 10 milliseconds, which is basically the frequency response of the hydraulics, right? It's super good, and you'll notice it when you drive it. It's really competent on the highway, but when you go off-road, it's also super comfortable. It's not harsh and whatnot. And we can keep the body roll down, the pitch down. I mean, it really does drive like a Tesla, and that's something that we really, really wanted it to be. Not this unwieldy, big thing, but like feel small, nimble, like a sports car, like every Tesla's made, have 0 to 60s of 2.6 seconds and all that torque. Then we had to really add this to unlock it.
But it's not, it's not pitching like crazy in response to the torque. It's very settled and comfortable drive.
Well, this people are asking me about, is this going to basically eliminate the Rivian or the F-150 or whatever? And I don't think that's going to be the case. What it is going to undo is Jeep. I mean, I never thought I'd ever, because I've been driving Wrangler since forever. But after they gave me I bought the new one. What a disaster! I mean it sincerely. I could not believe that they put that thing out. All right, so let me just ask a couple of quick questions.
Of course.
So it's steel, and you showing the 2 seats. Okay, so just kind of curious. I'm assuming there's more to this than
there's carpets and center consoles and other things that we're missing. Wire harnesses and
that all get married.
And is this? I'm assuming it's the 4680 batteries.
4680.
Are these the new dry cells?
This is the 9% higher energy cell that we're making in Texas now.
Yeah, but it's dry. It's not like the because that's what I saw when I came here with the investors. Where's the shrimp? That's the only thing I can remember. I heard it twice.
Really?
So yeah, they had no idea what they were looking at, and I was about peeing my pants when I was watching the anodes being
electrode produced here.
Yeah. Cool. Okay, so let's look at the trunk, and then we can go out on the floor, or frunk, whatever.
I know you did the teardown of the Model Y structural battery. Like we've certainly evolved it. We would call the like Model Y structural battery maybe like a grade C.
This is interesting.
This is more
right
of a
here.
grade
I mean,
B.
you can already see some of the ground clearance. So this is
Yeah.
the suspension and basically off-road mode, and it's a flat floor. There's no diff hanging down in between, so you get true ground clearance.
For off-roading, we've also leveraged all the work that we did on our own in-house stability control, like for track mode, to apply like more dynamic behaviors for off-roading, both rock crawling and for like Baja.
Well, I can put 3 shotguns in here, or 2 long rifles and an ammo box.
Yeah. And you have a, like it kind of opens at an angle, but you have this sort of clamshell design where it's an L this way and an L that way, so you get, you get a box section for it. I'm gonna try and pull that out, but this is that. Never get my fingers in there.
These fingers don't work.
There you go. This is another cool thing. We're trying to focus on service. So that's your HEPA filter replacement right there. It takes about 2 seconds.
Oh, wow.
So you just unclip those, pull it out, and put it one in. You do it right at home.
Yeah. Okay, let's just, if we can look at the ramp, then that would be great too. Oh, maybe not. I think somebody put a pillar in the way here. Oh, very good. Oh. Oh, and you got another...
Yeah, we got some under bed storage here.
That's where you put groceries. I mean, really, right?
It's wherever you want it, man.
Actually, the one thing I've always loved about the Model 3 is the Model Y and the Model 3 is the ability to use that in the front as your ice chest. Yeah. So.
Yep. Drain hole in the bottom.
And there you go. See, finally Ford gave you something.
But look, custom Cybertruck logo.
Oh my God! Look at that.
It's one of the few logos on the truck, by the way.
There's no Tesla logo.
There's no Tesla T or
Really?
Tesla badging anywhere on the truck.
You don't need it.
Yeah.
Exactly.
What?
Exactly.
I mean, save
so
the
we
money.
we save the money. We save the weight.
Wowzers. Way cool. Okay, so I just got my head filled to overflowing with information. I'd like to thank all you guys for helping me out. Lars is going to take me on a little inside tour here, but I really appreciate you giving out your time and basically sharing with our audience. This is going to be a brilliant video. So anyway, thank you so much.
You're welcome,
Appreciate
Sandy.
it.
Thanks
Thank
for coming.
Definitely.
Thank you so much.
Nice to meet you.
Yep.